Assalamualaikum to one and all. In today's episode, we analyze two questions that relate the size of the nucleus of an atom to its number of nucleons. Is it true that the higher the mass number of an isotope, the bigger is its nucleus? Find out by hanging around, watch, and learn. Question number one. The nucleus of an atom has a radius of 5.61 raised to the negative 15 power meter. If the nucleus contains 45 protons, how many neutrons does the nucleus contain? Take note, no periodic table of elements allowed. Choices are letter A, 50, letter B, 57, letter C, 69, and letter D, 102. Question number 2. The nucleus of a particular isotope of beryllium contains 4 protons and 5 neutrons. Which nucleus has a radius that is approximately 3 times that of this isotope? Letter A. Is it aluminum, whose mass number is 27? Or is it letter B, plutonium, whose mass is 243? Or is it letter C, barium, whose mass number is 135? Or is it krypton, whose mass number is 81? With the exception of protium, the isotope of hydrogen that has a proton and no neutron, all nuclei of atoms basically consist of the positively charged protons and the uncharged neutrons. The nuclear size of any atom is described in terms of its nuclear radius, denoted here by small letter r. This nuclear radius, small letter r, is approximately equal to the product of the cube root of capital A and a constant equal to 1.2 times 10 to the negative 15 meters, where capital A refers to the mass number of the element or an atom. All right? It is also the number of the positively charged protons and the neutral neutrons, and they are collectively called nucleons. So, if X is any given element, all right, the superscript capital A is defined to be the atomic mass number, right? While the subscript capital Z represents the number of protons in the nucleus, or is also known as the atomic number of the element. Alright, so let's now proceed answering question number 1, where we are given the nuclear radius of the nucleus equal to 5.61 raised to the negative 15 meters. Alright, the atomic number of this nucleus is also given, capital C equal to 45. So that means there are 45 protons in this atom. Our target variable is to determine the number of neutrons, capital N. And using the equation for determining the nuclear radius, small letter r, nearly equal to a constant 1.2 raised to the negative 15 meters, and multiplied by the mass number, capital A, or the cube root, all right, of the mass number, capital A. And since we need this mass number, capital A, in order for us to determine the number of neutrons, there is a need for us to isolate capital A, right? So isolating capital A, we get this working equation, capital A nearly equal to the given nuclear radius, small r, to be divided by the constant 1.2 times 10 to the negative 15 meter. All right? So the result of r divided by this constant will still be cubed, right? So um, substituting the value of r, we get 5.61 raised to the negative 15 meter, and that is to be divided by 1.2 times 10 to the negative 15 meter, and then get the value or the cube, right, of the quantity in the parentheses. So you doing your math, we will be able to get the quotient, which is 4.675. All right, but that still has to be cubed. And finally, we get the value of capital A, that is the mass number of this isotope or atom is equal to, or nearly equal to, 102, right? So by definition, capital A refers to the mass of the proton, or the number of protons, plus the number of neutrons. So therefore, since we are given the number of protons, which is 45, the number of neutrons, capital N, therefore, is just equal to A minus capital C, or 102 minus 45, and that gives us the number of neutrons of this atom, which is 57. And so, our answer to question number 1, therefore, right, is that um, the nucleus contains 57, right? 57 neutrons, and that makes letter B as our correct answer for question number 1. For question number 2, we are given the number of protons, capital C, of an isotope of beryllium, and also the number of neutrons, capital N, which is 5. So that makes the mass number of this isotope beryllium equal to 9. So the nuclear radius of this isotope of beryllium, which is denoted here by R1, is nearly equal to a constant K multiplied by the cube root of its mass number, or the cube root of 9. Okay, where of course the value of K is equal to 1.2 times 10 to the negative 15 meters. Alright? So our target variable is to determine the mass number of an unknown nucleus, which according to the question, right, its nuclear radius R2 must be 3 times as large as R1, right, or 3 times the nuclear radius of this isotope of beryllium. So just like R1, we can also express R2 as being nearly equal to the constant K multiplied by the cube root of the mass number A sub 2. Alright? Since we're looking for the mass number of this unknown nucleus, capital A sub 2, okay, we are going to isolate that and come up with this equation for A sub 2, which is nearly equal to 3 multiplied by the constant K and the cube root of 9, and then divided by the constant K. They are all inside the parentheses. Okay. The value of that quantity inside the parentheses still has to be cubed. Alright? So if you're going to simplify by canceling the constant K, the simplified version now for A sub 2 will be bracket 3 times the cube root of 9, alright? And the quantity inside the bracket still has to be cubed. And further simplification will give us this, alright? 27 to be multiplied by 9. 27 is the result of getting the cube of 3. And the cube root of 9, of course, when you're going to get the cube value, alright, of that, that would still be equal to 9. And finally, the value for A sub 2, or the mass number of the unknown nucleus, is therefore equal to 243. So going back to question number 2, which nucleus has a radius that is approximately 3 times that of this isotope? Alright, so based on our preceding answer of finding the mass number of the unknown nucleus, it looks like that option number, or letter B, alright, is the correct answer. Okay, the unknown nucleus is plutonium, whose atomic number is 94, meaning there are 94 protons, and its mass number is 243. So that concludes our tutorial for this topic. Till the next episode, mabuhay. Alhamdulillah, Masya Allah. Thank you very much for watching. Please follow me in my FB page, and please don't forget to subscribe to my YouTube channel.